Hello, it's Sean doing the derivative example, which is using, or at least mine, using the derivative to find the marginal and marginal profit. Uh, you can find this back in module 4, but for this question, a candy bar company is trying to determine their marginal profit for producing candy bars this past year. Given the profit function negative 0.005x, that little up mark denotes raising a number to a certain power because Paint sadly does not let me do that in text, but when I write, it will. So as I was saying, negative 0.005x to the second power plus 7.5x minus 340 and answer the following questions. Determine P, forgot the P, of 700. And then for question 2, determine marginal profit at x equals 700. Number 3, estimate total profit after 701 candy bars are sold. And then lastly, estimate total profit after 702 candy bars are sold using the marginal profit at x equals 700. And side note, P of x is in hundreds of dollars and x is the number of candy bars sold and produced. Okay, so for the first question, determine P of 700. And for all these questions, I'll interpret them. So for the first one, let me get the pencil out for the first one. Okay, so they want to know what the profit will be after 700 computers are produced and sold. So you simply take the profit function that is given, which is negative 0.005, and you input 700 for the x in all of them. So therefore, it'd be that you put 700 in plus 7.5 times 700 minus 340. And I already did the math. So after doing this, you would get 2,460, but do remember, as the side note says, it's in hundreds of dollars. So therefore, you'd have to multiply it by 100, therefore giving you 246,000 candy bars produced and sold. Or that's the profit after 700 candy bars are produced and sold. Okay, and let me go to the eraser real quick. Okay, and for number 2, they want us to determine the marginal profit at x equals 700, which is basically asking us to, or it will give us once we're done, once we find that, it'll tell us the change in profit of the x plus 1th item, in this case being the 701st, or yeah, 701st item. If I can erase quicker, give me 1 second. Okay, that's good enough. Okay, for number 2, you have to start off by taking the derivative, because that will give us our profit function. So therefore, the profit function is given there, so I'm not going to rewrite it, but p prime of x will equal, and this is where you take the derivative. So you have, let's see, derivative of x squared. Well, usually with this, like we learned, you take the exponent and you multiply it by the coefficient, and then you subtract that exponent by 1. So that will give us negative point, oh man, hopefully it's easy to see, negative 0.01. And then the derivative of 7.5x would just be 7.5 because x is to the first power, and then the derivative of a constant is always 0. So we're left with negative 0.01 plus 7.5, and that is just one part of the riddle. And now to find x at 7, or x equals 700, we have to input it into the derivative function. So let's do that. P prime of x equals, and you just, oh, I forgot my x, oops, I forgot my x, and you throw it in, so you get negative 0.01 times 700 plus 7.5. Once again, I already did the math. I already did the math. So therefore, you will get 14.5. But once again, remember it's in hundreds of dollars as the note says. So therefore, you multiply that times 100, and you would get 1,450. And that's the profit of selling the 701st item, or at the 701st item. Okay. On to the third question, which to the third question that asks us estimate the total, or tells us to estimate the total profit. Estimate the total profit after 701 candy bars are sold. Okay, so give me 1 second. Let me erase all this. Oh, this takes a while. So yeah, in the second question, we had just solved what the profit would be after selling the 701st item, but now it wants to know how much profit in total after selling 701 candy bars would be made. And I will do that in a minute. All right, so on to problem 3. I'm not going to rewrite it. Okay, so P of 701 is approximately the total profit, 700 that we already figured out at, or yeah, and then, oh, I messed it up. Oops, oops, oops. My fault, my fault, my fault. Looking too far ahead. I have a P of 701 is approximately, it'd be the price of finding it at 701 plus the profit of marginal profit that we found at at 700, which we had already worked out in the earlier problem. So therefore and that was the first number, so therefore that will give us 246,000 plus the number we had just gotten for the 701st item, because we were looking for the change in profit. So the total profit after selling 701 candy bars will be, and I already worked this one out too, so you get 247,450. And that's the total amount of profit after 701 candy bars are sold. Okay, on to question 4. I might just speed it up. I only have a 15-minute time limit. Okay, so onwards to the last one. All right, so for problem 4, they want us to estimate the total profit after 702 candy bars are sold using marginal profit at x equals 700. More, no problem. See the so P of 702. Pardon my writing, I'm not the best with this stylus. So P of 702 is approximately the total profit at 700, which we had already worked out, of 700, plus 2 times the marginal profit. Give me a second, we're not in a room. P prime of 700, which we already worked out. And it is 2, as you remember, because we were trying to find, or we were looking for the x to the 1th item, but now obviously if it's 2, then it's 1 more. So, and that's why we add the 2. And it's kind of hard to see, but that's supposed to be a plus sign times, so plus 2 times. So inputting the numbers, which I already worked out once again, you get 240. Oops, sorry. So you get 246,000 plus 2 times the 2 times 1450, because that was the profit we got, and that will give you 248,900. No, it's really hard to read. And therefore, that will be the total profit after producing 702 cookies. And then as far as the graph goes, graphically, I will insert a graph onto the Google slide itself that will demonstrate and explain this graphically. This is just mathematical. And thank you and bye.